Okay, hello everybody, and welcome to the Zcash Arborist Call on April 17th. On the agenda today, we have core stack updates from the Zcash Foundation, ECC, and Zingo Labs, research and implementation updates from Kedit, Shielded Labs on a few topics, and the Zcash Foundation, and then a section for open announcements and discussion. What are Arborist Calls? Arborist Calls are bi-weekly calls where Zcash protocol contributors convene to discuss upgrade timelines and process protocol R&D efforts, design and implementation of new protocol features, and identify blockers and unresolved issues. The purpose of the Arborist Call is to make core Zcash development accessible for a wider set of participants and provide more transparency for the community at large. Anyone can participate. Anyone interested in learning about the Zcash protocol development can register at zcasharborist.org. And if you would like to suggest a topic for discussion or present an in-depth agenda item relevant to the Zcash protocol, please email arboristcall@zfnd.org to request a slot in the future. Other ways to get involved in the Zcash ecosystem. We have Zcash community grants. You can check out what they have going on both on the forum, X, and zcashcommunitygrants.org. There's the Zcash R&D Discord, the Zcash community forum, and you can find all these links by going to zcasharborist.org. And kicking us off, we have the Zcash Foundation presenting on Zebra as part of the core stack updates section.
So
I'm not sure who that. Okay, thank you, Arya.
Zebra, since the last update, we've merged PRs that fixed an issue around Zebra attempting to overwrite user-mounted config files in a Docker environment. Fixed an issue to allow for running the tip height and copy state commands while another instance of Zebra is running and using the same database directory. To more closely match Zcash's get address transaction IDs RPC by making the start and end heights optional, and the get raw transaction RPC by adding several more of the missing fields to its verbose or object formatted output, and the get peer info RPC by adding inbound peer information. We also removed the get block template RPC's feature because it was just superfluous, merged in a v6 transaction num variant behind a feature flag, and in flight, we also have work being done to deduplicate the logic that's common between Zebra and the Sensu millicrate, restore the internal miner, match Zcash's get address balance RPC more closely by adding a received field to the output, and adding value pool information to the get block RPC's output.
Great, thank you, Arya. Any questions on Zebra? All right, we'll jump to the next update from ECC regarding Zcashd, core libraries, and Zale.
Okay, so first bit of news is Zcashd. There is a new release out today. There's about I don't know, 8 or 9 days left before the current Zcashd 6.10 EOS halts, and so 6.20 is published to all the normal places, the app repository and Docker Hub as of today. So if you're listening to this call, it's time to upgrade your Zcashd. The other things that have been happening in the past couple of weeks, we have merged a bunch of functionality to Zale that brings us much closer to our functional alpha. The last remaining piece there is getting zsend many working, and that is currently in progress. The other major effort that is in progress on Zale is decoding and migrating wallet data from the Zcashd wallet.dat format via the tools that the Blockchain Commons folks have built for their ZWIF wallet interchange format. The ECC core team is heavily involved in making and updating and tuning what they've done for that wallet interchange format, and so that's still going to be an evolving process for the next few days, but hopefully in the next, I'm going to say, week or so, we should have, or certainly by the next Arborist call, we should have the rudiments of Zcash wallet migration and the ability to then sync and send from that migrated Zale wallet implemented. Strad, is there anything that there's also a bunch of work that Strad's been doing on updating upstream or our own upstream crates in the crypto ecosystem. So the ZK crypto crates for, groups and the FF crate and so forth to the new RAND crate or new RAND crate release. Okay, now Strad, is there anything else that I am forgetting?
As far as it affects Zcash core libraries and Zale, I don't believe so. DC asked a question about 620 removes create raw transaction. It moves it under a, well, I think at present it is simply deprecated. It is not removed. But we do plan to have a mechanism for partially creating and updating transactions, but that will be done via P's and T's.
All right, thank you, Chris. Any questions from panelists or in the chat? Let me double check. Okay, we'll jump to the next topic. Do we have folks from Zingo here? It looks like that's a no. If anybody joins, we can circle back. Or does anybody want to say anything about Zano in general?
We've been working pretty closely with the Zano folks to sort of figure out the impedance mismatches between what we were expecting for Zale and what Zano currently implements, and I think that we're making forward progress on a sort of a common path towards having a nice set of APIs and the proper separations between Zano and ZebraD and so forth. So. Lots of interaction between the different entities in the ecosystem is happening right now.
Yeah. Cool. Thank you, Chris. Next up, ZSAs from Keddit. I see Pablo up here.
Hi, guys. We are getting closer to finalizing everything needed for the zips, for the ZSA zips. We had a nice discussion with the ECC people this week to close the last bits of these zips. In the same time, we are also having the reference implementation prepared. And there as well, we need to do these final touches for the reference implementation. We got this week a review on the Sensimilia crate and our PR for Halo 2. We also got a review from ECC, initial review on the Orchard crate. The Orchard crate is quite large, quite extensive. The changes required for ZSA are quite large. So at least we started this discussion. I also responded to this initial review today. This is for ZSA, so we are getting closer. At the same time, we are doing atomic swap work. So basically, we prepared an atomic swap version of Orchard, where unlike Orchard ZSA, where we have one action group, for atomic swap, we allow multiple action groups. Every participant can send the action group, and then it is combined all together into one bundle in the atomic swap version of Orchard. So we prepared the branch for this, and it needs to be propagated all the way up, meaning we have also a Libras Zcash branch for atomic swaps. Also, we have the TX tool version. We have the TX tool version for Orchard ZSA. We are using it to test Orchard ZSA against Zebra, but we need a different version for atomic swap. So we have this as well. And now we are preparing the Zebra version for atomic swap. So this is also in progress. I would say it progresses nicely, and we will have something working for atomic swap pretty soon. But again, the emphasis is on Orchard ZSA, not on atomic swap. We do this in the background, but the entire attention is on Orchard ZSA now. First of all, handling the reviews, and then propagating the changes up to the entire stack, Libra, Zcash, and Zebra. And that's the update.
Thanks, Pablo. Any questions? Double check the chat. Okay. Okay. Thanks again, Pablo. And next up, we have Shield Labs with the NSM. I believe this is Mark.
Hey, folks. Yeah, the NSM PRs were rather extensive in their number of changes and files updated because of all the transaction v6 and network upgrade new 7 enum variants in Rust. And between my and I believe Paul's pull requests to Zebra, which handled the transaction, the network upgrade enums respectively, our hope is that the NSM PRs will be much smaller and much easier to review. So that's the aim there. One of the PRs I mentioned has been merged, mine, and then we're still waiting on the NU7 PR to be merged. Once that's taken care of, which it looks like it's very, very close to being taken care of, then we'll move our attention both to the NSM PRs and the Libra Zcash PR that's required to support that under the hood. And that's where we're at. All of this is all feature flagged and all that good stuff, so it's all safe to review and everything.
Great. Thank you, Mark. Any questions? All right. We'll jump to the next topic. Crosslink. I'm not sure who's taking this one.
I can take this one. I actually have a video to show. Do I just share my screen and let the audio handle itself, or how does that work?
Let's see. If honestly, I'm not 100% sure if audio will work. Let's see if you why don't you try sharing your screen? Let's see if it boots me.
Okay.
And if not, I'll stop sharing here actually, and then let me stop sharing. Okay, let's give it a try, Mark.
All right. I'm just gonna hit play and just let me know if there's a problem with the audio, I guess. So almost go for it. Let's see. Oh, hold on. Oh, like that. There we go.
Hello, everybody. This is the update from Shielded Labs for today's Arborist call. In front of you on your screen, we can see the viewer that you've seen before from the last time. But now, this week, we worked on addressing a lot of technical debt to do with our Malachite integration. And that was in order to be able to switch to arbitrary payloads for the BFT. So I can propose a message here. I can say, hello, Arborist. I'll do /Sam. Now my node is proposing that. And so when it becomes my turn to create a block, we should see it appear on Andrew's screen, which is in front of you. It might also help if Andrew proposes a block as well. This is not exactly the intended mechanism of how this is supposed to work inside Malachite. Are you proposing, Andrew?
Another block is proposed. Yeah, we'll see what happens. So we can see in the background that the rounds are increasing as we try. And as I say that, we have our message from Sam, and then message from me.
Yes, these can run in very quick succession. When right now there's a round robin between the finalizers or proposers, and what's happening is things can get a little bit clunky if we don't propose, because then it has to stall for a round, etc., and then eventually get passed around to somebody who is proposing. But I can propose again. And well, we can see this mechanism. There we go. See, it took a little while, and again, I think the time you could the you know, a tentative view of this could time how long that took. I think it's probably going to be 2 to 3 times 5 or 6 seconds or something if you count the timings. Anyway, so that's on the Malachite side. We also have updates on the actual visualizer stuff. Andrew, what have you been working on this week?
Right, so the kind of core thing with the visualizer that's new is the ability to have nodes that branch off one another, and as they get put onto the visualizer, it uses a force-directed layout approach to make sure we have a kind of balanced tree, and we can generate a tree or a bunch of side chains for either chain, and that is going to be among, as well as just being able to view the data, we're going to be able to use this as input for tests. We also currently have a setup so that tests can output data and then we can import it into our visualizer, just to make sure that we have a decent mental model of what the test is actually working on.
I should say as well, we have since last time fixed up support for syncing, so you can turn a bit off and then turn it back on again, and it can connect to the network and resync back up. We're still working on some connectivity stuff to do with, I want to get punch through done. We'll see if we end up doing that, for NAT traversal, because it should just be something we can turn on in the P2P. But yeah, do we have anything more to share this week?
I think that's the main stuff for this week, but we'll have some more pretty soon.
All right, see you all in 2 weeks.
See everyone.
There we go.
Great. Thanks, Mark.
Yeah, no problem.
Are the slides back?
Yes.
Okay. Any questions, comments, thoughts on what we just saw, or anything else related to Crosslink? All right, we will jump forward. Next up is the ZF on Frost.
Yep, that's me. We've been working on addressing the final 2 comments from the audit, suggestions from the audit, basically improving the structure of the project or the demo. So we did that. It's just those PRs are under review, and we should get those merged and wrap it up. This part of the project, from the findings from the audit, soon. And that's mostly it for the project. I often see some confusion about the status of the Frost project overall, taking a big step back here. So just to make clear to everyone, like the first thing, the Frost implementation itself of signing, generating signature shares, aggregating, and whatnot. This has been implemented in the Frost core and the Cypher Suite crates, and it has been audited and was published in 1.0.0 release beginning last year. So that's been ready for a while. Since then, we've been working on because that's just part of the puzzle, right? To run Frost, you need people to communicate with each other, send messages back and forth, and that's not handled by the core Frost crates. So we've been working on some. We started with a demo to show how it can be done, and we iterated on it until we arrived at two tools called Frost Client and FrostD, which is a Frost server. And these tools allows you to run to sign things with Frost, particularly the cash transactions. And this is what was audited, and we're addressing those findings from the audit. And after we finish that, we basically wrap it up the Frost project SDF. So we have a tool that people can like a command line tool that people can use or can use as a reference to integrate Frost with their software. The only things that will probably work at some point, we want to add PCCT support for this tool. And this is something that probably will happen at some point. It's not scheduled yet, but it should happen, I don't know, in the upcoming month or so. And that's basically it. Like a long-term view, like we like to have Frost integrated with wallets, right? But this is not something we can work on ourselves, but we're willing to help other people to do that, and that's mostly it. And I think there was some chat about zip 312, which is a zip that would specify how to use Frost with Zcash. I think there was some suggestion from Strad and Daraema related to quantum resistance or something like that. We're happy to change it. The zip is basically on a state that is blocked on other people reviewing it and offering feedback. So if you're interested in it, please give us feedback. But I might revisit it, just update the zip and ping different people in the ecosystem to see if you can get unblocked and approve it at some point. But that's it. That's the whole picture for the Frost project SDF. So if you have any questions, feel free to ask.
Thanks, Conrado. Any questions or thoughts?
Yeah, the regarding the remaining things for zip 312. Yeah, the thing that was left outstanding at the time that zip 312 was merged was primarily key generation. And then there is another PR, I think, that's open for randomizer handling. For the tool, are you aware of anyone currently actually attempting to deploy Frost within Zcash? Because regarding the quantum resiliency things, the approach that we've been thinking about is very dependent on no one having actually deployed Frost yet.
I'm not aware of anyone. The main thing is our own Frost client tool, but that can easily be changed. But I'm not aware of any other implementation of.
Great, fantastic. So we still have the chance to get the key structure for Frost done in a way that is quantum sound. Cool, thanks.
Yeah. I'm kind of curious. Like I really don't. I haven't looked into it, but I think Frost is not quantum secure, right?
Well, I can give a quick overview in
Sure.
the open discussion at the end if people want.
Cool. Thank you.
Great, thank you, Shred. Any other questions or thoughts? All right, we'll circle back with what Strad mentioned later and jump to the next topic. Open announcements. So, yeah, please raise your hand if you have an announcement. Okay, we'll jump into discussion. And maybe before we get to what you mentioned, Strad, I saw Sean Bow is not able to come up. Did you still want to type anything out, Sean? I'd be happy to read it or drop links or anything like that. And then there was, the blog post. Okay, yeah, please check out that blog post. It was retweeted. There you go. There's the link. seanbow.com/blog. Okay, and then there was another Paco, do you want to jump in? On what you wrote?
Yeah, it was just a quick question on just to know, like, the CSA folks have been working like on their own playground for a long time, not because they chose to, but for other reasons. And I just want to know, like, how do you see like impacts, like new changes that are made into Zebra or all the code you're working on? How does changes on upstream is impact you? Are you up to date with the upstream code? Is there anything that we can do, I don't know, to mitigate or help you out? And if that's you know, if you see that, you know, going back to upstream is going to be a major thing. I think that was not a lot of clarity, and there was some discussion on a zip, in a governance zip that, you know, it created a lot of fuzz. It was kind of around this topic, and I guess that I think we probably have everything figured out, but I don't know if you want to give some feedback or comment anything about that. It's much welcome.
Sure. So the status update for this particular topic, meaning upstream updates, is that we are fully caught up with the changes to Orchard. The most significant change to Orchard that affected our work was the introduction of PCZT. We are caught up to this right now, and we merged our work on top of PCZT, on top of Orchard with PCZT included. We are not fully caught up on Libra's Zcash, where there was a significant activity in the upstream branch. We are preparing to catch up now. We made sure with the ECC people, with Strad just this week, that this is a good time to update to our version of upstream Libra Zcash, and we will be doing it soon. So to your concrete question, yes, every change from upstream, there is a price to catch up. That's the question and the answer. But these changes are specified. They are mostly part of the NU7 upgrade as discussed previously. So we will need to catch up. Anything that was not previously mentioned, also it is possible to catch up. There is a price. We are doing this. The most significant parts, though, which are the circuit, Halo 2, and the dependencies, are not being changed for significant amount of time, and both the ZSA work on top of Halo 2 and on top of Sensimilia is considered stable, and the circuit. So the critical parts are not moving, and this is important, and this is good. Otherwise, with Orchard, yeah, we are up to date as of now.
Excellent. I suppose so, but it's always great to just make it clear. It was not apparently clear for some people. Thank you.
Thanks, Paco and Pablo. Any other thoughts on that or other open discussion topics? Just double check the chat. I do not see anything. Okay. Thank
I've
you
got
all for.
I've got
Sorry,
the.
Chad.
Yeah, sorry, I thought you were asking for other
Yep.
things.
Yep.
Okay, so if I, where's my window gone? Here we go. If I quickly screen share this one specifically. Okay. How does that look? Do I need to make it shorter? Would that help
Looks
people?
good.
Is there anyone who can't see this clearly? I will take silence as a no. Okay, so the general idea, and so Derima has been writing this up and is preparing a zip draft for this. But this is an idea that came out of discussions at Rural Crypto short time ago. And the general idea is that obviously the current Zcash protocol is not quantum sound. So if a quantum computer comes along, then they can counterfeit funds. They can spend arbitrary money arbitrarily. And the reason they can do that is because the way that note commitment works is not quantum sound. So you can take an existing note that exists in the tree that you don't know the note details for, and with a quantum computer, you can trivially find a note that will satisfy that note commitment. And I won't get into the details of why that's the case, but basically you can generate any note you want that has the same commitment as some existing note commitment, but a different nullifier. And so that's Derium has gone into detail in this in her quantum related Zcash talks at previous Zcons. The idea that we had is basically to consider that a quantum sound circuit, all you need to do is prove knowledge of some kind of information associated with the note. And so via something that is quantum safe. And we already have something like that in the current note payment protocol, the Blake-2B hashes that are involved in deriving various information that goes into the note commitments. Now, there's aspects of this protocol, like the witnesses, the input information into the proofs are things like this row value down here, psi, RCM, the value and the address. So these pieces are inputs to the pre-quantum circuit, the current circuit. But this part down here, the derivation of RCM from RSeed and psi from RSeed, this is all done for. There's a couple of reasons that it's done, but one of the reasons is that then in the note plaintext, we only convey RSeed. And then you can derive things like RCM and various other ESK and other values from it. So the idea is that if a quantum computer comes along, you can still spend notes created under Orchard. You just need to additionally make a few changes to how you produce them. And essentially what you're doing is you're leveraging the fact that we already have this hash deriving RCM in the wallet level protocol. And we're providing everything else that goes into note commitment is then changed to also be an input to this RCM hash. And the upshot of this is that then you can then show, and Derimer has some security arguments that he's putting together, show that by doing that, you correctly bind, even though note commit is not quantum sound itself, given a particular CM, and then given if you check this hash in the circuit, it constrains you down to having like either one or two possible RCM options per like attempt. And so you basically turn grinding on the commitment to grinding on this hash, which is quantum hard under various assumptions. So that approach, which is going to be sketched out in the zip, basically allows you to start generating notes in the Orchard circuit that will, if a quantum computer comes along, still be claimable under what you would do is you would write a circuit that proves everything in the current circuit, plus also proving this hash. And so it's proof of knowledge of the inputs to this hash that is the thing you use to spend.
So there's a bunch of details in it. I've not covered everything in here, but the zip draft, once it's up, will cover those details. But this essentially means that you can have it becomes a fallback whereby you have what would be a very slow post-quantum circuit, but a circuit that does hopefully work and provides quantum soundness. Again, this would all need to be checked. But assuming that that's the case, that solves that part of the circuit, which is the payment protocol. Basically, wallets would then need to spend all of their existing notes into new notes in the orchard pool after their wallets were upgraded to generate notes in this way, and then all notes from that point forward in the wallet would be quantum recoverable, whereas notes that were just sitting around previously would be quantum vulnerable. And by quantum vulnerable, I essentially mean that you would lose that money if you didn't, before the quantum computer came around, migrate your notes. Because obviously once the quantum computer comes around, we will just turn off the vulnerable circuits so that people can't, quantum adversaries can't like mint funds. The downside being, of course, when you turn off that circuit, people who haven't done this migration would then lose access to their funds. But this essentially provides hedging and a way for people to potentially in advance make their notes quantum recoverable. Anyways, that covers this particular note commitment there, which has this problem. But there's another one down here, the commit IVK, that has the same problem. It's a similar quantum vulnerable hash, and the same thing applies to it. And we can take the same trick to derive it in the same way, where at the moment in the circuit, we take AK, NK, and RIVK as the witnesses, but RIVK is derived from a hash currently. In fact, all of these are derived from hash. So you can also do the same trick and have proving knowledge of the spending key of SK in Orchard's case as the new proof of spend authority in a post-quantum world, so that you can do the same trick for the long-term recovery key. However, there's a difference here, which is that the note logic is one time. So because the way that UTXO model works, every note is generated and then spent and then never used again. So you don't need to deal with long-term state for your existing notes. You can spend them all, and then you don't need to worry about your previous state for quantum resilience. But e-material is intended to be long-term. So we have this legacy case here where we have this part that's proven in the pre-quantum circuit, which is AK is technically in here as well. AK, NK, and RIVK are all inputs to this circuit. This is quantum vulnerable in that if you only have AK, NK, and RIVK as your inputs, then you can pick an IVK and find any AK, RIVK, and NK that will satisfy it. So you need to bind those three inputs to some prior input. Now, for existing key material derived from via zip32 for Orchard, the only suitable thing is the SK value. And as a side note, this is also why we're not proposing this for sapling, because there are details in the zip32 derivation for sapling that make this significantly more complex and harder, and it's just not worth the time to figure that out. But essentially, what you end up doing is you're proving knowledge of SK, and so that becomes your spending key rather than ASK being doing a Schnorr signature using ASK. The other thing that we note in this diagram is that if your SK value is on a hardware wallet like a Keystone, then you still can potentially, in the post-quantum recovery case, maintain hardware wallet compatibility if we can figure out a hardware wallet compatible proof that you can do inside the circuit that proves 3 Blake 2B hashes. That's going to be very expensive compared to like post-quantum friendly hashing. But if we can figure out a way to do it, then you can keep your SK inside the hardware wallet and in a post-quantum world. If we can't figure that out, then to recover your post-quantum your funds from a hardware wallet in a post-quantum world, you would have to take that SK value off the hardware wallet to be able to make this proof, to do the recovery proof. So the reason that I brought up Frost earlier is because we can't change this key tree. People are already depending on it, and trying to make this more optimal for the hardware wallet case would cause way more problems in terms of discovery and deriving of funds. everything we've done with like the other protocol upgrades and things we've done, we don't change the structure of a key tree once we've defined it, particularly the HD key trees. However, as I noted, Frost hasn't been deployed yet, so we have an opportunity to structure its key tree to be more efficient in this case. Now, note again, this pre-quantum circuit, same as before, it's just taking in currently the AK, NK, RIVK values, which is essentially the viewing key. And then normally this ASK to AK step is proven with a Schnorr signature. So that's the Spendorf sig in the protocol. And so what we could do, if you have the flexibility to change the key tree, so you could do this for potentially a more efficient PQ hardware wallet, if you accept the fact that you run into all these semantic problems. So I'd rather not, but if you're willing to do that, then you can change the structure of this derivation so that the only thing you have to prove in the post-quantum circuit is this hash deriving RVK that takes AK and K and this extra value that we derive QK, sort of the quantum key, which is essentially inserting an additional, like, it's turning this leg of the current current tree from one hash into 2 hashes. And what that means is that in the case where you can do things on the hardware wallet, now the only thing you have to prove on the hardware wallet is this circuit on a single. We would still use Blake to be for this because we have to use Blake to be in other places, but a single Blake to be hash rather than 3 of them, which is smaller and therefore more likely to possibly be hardware wallet compatible. Or maybe we look at other like potential hashes we could stick in here for this that might be even easier. But the other thing that this gives you in the case of Frost is graceful degradation. So if you're using this normally in Frost, this part would just be done inside the hardware wallet or inside whatever Frost is doing. This derivation of RVK and NK has to be known to all Frost participants. The ASK value is the thing that's sharded amongst the participants, and AK is the group key. So this dotted line here only exists for the hardware wallet case. This dotted line does not exist for Frost. ASK is just like a floating value. So the thing here is that in the case of a quantum adversary coming along, this link breaks. So you no longer can use the threshold mechanisms. But you can still prove a spend by proving this QK hash over here. So your Frost multi-signature degrades from K of N multisig, whatever you've defined, N of N or K of N, it degrades down to 1 of N multisig effectively, because you just need to prove knowledge of this QK. And presumably all of the Frost signers have knowledge of that. Maybe all of them have it stored on a common hardware wallet, or on hardware wallets of their own, however, or just they have it in their secret key material along with their shard of ASK. But what this means is in the interim, where say as a community, the Zcash community believes that quantum adversaries are too much of a threat to leave the pre-quantum circuit enabled. So we disable the pre-quantum circuit, we've moved to the recovery circuit along with whatever post-quantum stuff we're doing, and so you're required to prove this leg. You could still include the Schnorr signature as also being required. Now, obviously, if a quantum computer actually exists, then the Schnorr signature is providing no benefit. However, if a quantum computer does not yet exist, and we just are worried about the threat of one existing, then keeping the Schnorr signature here retains the multi-sig benefit. So in that interim period where globally we've turned off the pre-quantum circuits, but no one has actually proven a quantum computer to exist in generating false proofs, the Frost multi-sig stuff can still be used and still be retaining essentially K of N multi-sig in that interim, locally, like for the people who are using the Frost signatures, even if globally the network isn't relying on the fact that those multi-signatures work, or that pre-quantum stuff works anymore. So you get this sort of graceful degradation, which would also let you, in the meantime, hopefully a post-quantum sound threshold scheme would be derived, and then the people using those Frost keys could migrate over time, but they would still have a way to recover their funds, either in the sort of that interim sort of twilight zone via their current multi-sig guarantees, or in the fully post-quantum zone via this recoverable QK value that is 1 of n multisig effectively. Cool. Any questions?
I think I got it, kind of. The only thing I'm not sure about is the SK. Like for Frost, you don't need an SK, right? You can just generate the NK, RVK randomly or whatever.
Right.
So
But that's the
Go ahead.
thing. Sorry, what was the question?
No, go ahead.
So that's the insight that we have here. You can't generate them randomly, or else you don't get quantum resiliency.
Right.
The quantum resiliency comes from the fact that these are not generated randomly. They have some hash-based derivation that we can fall back on. So to clarify, like in the legacy case here, the post-quantum circuit, for rendering reasons, we only show this as the addition, but actually the post-quantum circuit would cover all of the pre-quantum circuit as well. We have the post-quantum circuit has to prove everything the pre-quantum circuit does, plus this addition. And the reason that it's sound is because we can rely on the hashes being derived in this way. So if you just derive NK and RIVK randomly and just make it known that all of the Frost participants know what the NK and RIVK is, and then they have AK as the group key, then that Frost group can never have quantum soundness,
Right.
have quantum recoverability, because you've got nothing to fall back on.
Yeah. So my question is, if we are going to adopt this, what would the Frost wallet need to store? They need to store the signature, the key share, but then SK or QK or both SK and QK. This is what I'm not sure.
So ignore this box for this.
Okay, yeah,
Darium
yeah, yeah.
put this in
Yeah,
because
yeah.
this is relevant for the
Yeah, yeah, yeah.
PQ hardware wallet case. But if you ignore this box, the minimal that a Frost participant needs to store is their key share,
Yeah.
and then whatever is necessary to derive the rest. Having an SK value makes it convenient because you just store that one SK and you can derive everything you need. But if you didn't want to do that, then you would need to, if we adopted this kind of approach, you would need to store NK and QK.
Okay.
And QK in particular would be sensitive spending material. NK is just viewing material. So the advantage to deriving this all from an SK value is that it retains the simple property of you just have a single spending key datum that derives your viewing key material, other than the fact that you have the ASK share here.
Yeah. Got it.
It would be convenient if the ASK share could in some way also be derived from something, if there was some way to ensure that this could be bound in some way. I don't know enough about the options for doing Frost DKG in terms of what they can do in terms of resiliency, but if it's guaranteed to be the case that each participant is going to need to remember something of their own, and if there's no good way to have like SK or some equivalent of it derived from the group SK, then like another option here, just like spitballing, would have been to derive NK from AK, which causes problems in your proofs, because there's part of the reason why we use an SK in the other protocols, because then you can treat this layer of the protocol as basically these are independent values. You can model them as independent values, where if we have NK derived from AK, you don't get that property. And here we're actually intentionally deriving RIVK from these two. So yeah, it becomes a bit tricky. You certainly could not derive to have quantum resiliency. You could not derive QK from AK, because otherwise AK is viewing capability material. QK is meant to be spending capability material. So you cannot have spending capability material derived from viewing capability material. And since you couldn't have it derived from the individual ASKs, because each of those is meant to be separate, and you're never supposed to combine them together, you couldn't combine them in a way to produce the QK value. So it's kind of necessary in this model to have sort of a minimum of the key shard and something, either QK or something that derives it. But yeah, you could, for example, model you could ignore QK here, for example, and just have SK deriving NK and also being an input here, but that also causes slight modeling problems. So that's probably why Darium has put this here. yeah, the simplest thing would just be to have this, the key share, the participants' key share part, and a seed value, a SK value that derives everything else they need.
Yeah, that makes sense. Thank you. Yeah, I think this is important. The only thing I'm thinking about is I don't think this is worth blocking for, like, if people want to use Frost now, I think they could. I don't think it's an issue if people generate Frost keys using the current way. Because I mean there's nothing settings. It's not as ossified as in regular Zcash, when you have a seed phrase and you need to make it work with the seed phrase forever. For Frost, you need to store your key share and whatever material you need somewhere. So I think, in my view, it's okay for people to use this, and then we add a new option, or you can now generate quantum resistant Frost wallets, and people can decide to migrate their funds to a new
I mean, that
Frost
just
wallet.
rolls into the exact same problem that we were looking at up here with the well, it rolls into the same problem as we have with sapling, basically, and to some extent here. I mean, this one, the problem with the legacy case here is just is the only problem is efficiency for hardware wallets, and this change here in the hardware wallet case. So in the hardware wallet case, these are fixed lines. The hardware wallet case, the only difference between these two is reducing the number of hashes you need to do inside the circuit. For the efficient hardware wallet. And of course, the nice thing about like the stuff that Sean's been looking at for scalability is you could support both of these at the same time, because these could just be different potential leaves in the PCD tree. So you could prove, you could have support for either proving the full legacy mechanism, or support for this mechanism, because either way you end up with you're placing a constraint on a hash constraint on the relationship between all of the inputs to commit IVK, and that's the core property that we're relying on here, is that the inputs to the quantum unsound commit function are bound via a quantum sound relationship. So yeah, the advantage to doing this ahead of Frost deployment is that then it's simple for people. And in particular simple for like wallet support, because then there's only one thing they have to define, whereas rather than potentially multiple things.
Yeah, I think in this case also, like, one really has to consider the UX of, if you're imposing a cost for key migration on your users in the future, key migration is generally not something that is good for users. And so if we can make the fix now before they would have to worry about that, then we should go ahead and do it.
Yeah. The only thing I worry about is, like, how long do you expect this to be, like, finished so we can implement it?
So in current conversations, we would like to deploy this alongside NU7. So the reason for that is specifically ZSAs. The advantage to deploying this everything that I've described here is just a wallet level change. This is not part of the consensus protocol, except this pre-RCM value does interact with shielded Coinbase specifically, because shielded Coinbase verifies the RCM derivation. And so if some notes have a different RCM derivation, then that would affect consensus. So you could either choose to not deploy it in consensus, at which point it would mean that any shielded Coinbase would never be quantum recoverable, or we accept that this particular change, none of the rest of this matters, but just this particular change, we allow it in NU7 alongside the other changes, and then shielded Coinbase is also protected. But the reason that it would be good to deploy this alongside NU7 is that no one has generated ZSA notes yet. So if every wallet is uniformly doing this approach from NU7 on, from the upgrade that deploys ZSAs onwards, we as developers and maintainers of the specs can assume that every single non-ZEC note is quantum recoverable. Currently, we cannot make that assumption about Zcash, about ZEC notes, because we have a bunch of notes in the orchard tree that are not quantum recoverable. So there's complexity in terms of sort of the migration process, whereby some of the notes in the tree migrating in this way would become quantum recoverable and other notes in the tree would not. And that leads to complexities and problems essentially with, in the same kind of way as we have with Sprout at the moment, where we can't distinguish between notes that people have the spending keys for but just haven't gotten around to moving yet, from notes that are unrecoverable and essentially like locked up, lost, burned, whatever funds inside the Sprout pool. We can't distinguish between those two. And so there's an ongoing protocol complexity burden to dealing with that. And there's a similar thing here with Orchard in terms of when you get to a quantum computer, some funds are going to get locked up and be lost essentially, because they cannot safely be proven spendable in the presence of a quantum computer. But some of them can be. And the advantage of deploying something like this alongside ZSAs is that we know that every ZSA note is provable in that way. So assuming that others agree with us, then the timeline for that would be relatively quick, which is also the advantage of this, is that it's a relatively small and easy to specify set of changes to the, because most of the complexity is really sort of on future us. Whenever the quantum computer actually starts being a threat and we have to define a post-quantum circuit, the complexity on the protocol now is just a few, adding a few more inputs to existing hash functions.
Got it. This is a consensus rule change, right? We need to change how.
For the most part, it is not. The only, as I said before, the only consensus rule that might be affected by this is the Orchard shielded Coinbase rule.
Right.
It allows you to create Orchard shielded Coinbase, because the Orchard shielded Coinbase is required to be decryptable, and we verify that the note commitment is correct, because you have to decrypt it in order to check that the value is valid. That the consensus rules verify this note commitment. And they do that because they decrypt and they then get the RC'd out and they derive RCM. So because the consensus rules specifically for shielded Coinbase check this pathway, we can either have zero consensus rule changes at all as a result of this change, at the cost of shielded Coinbase outputs remain quantum vulnerable, as in quantum loss. Or we can choose to add an additional consensus rule change that allows the shielded Coinbase note plaintexts to have the version that does derivation in this way, and then shielded Coinbase outputs become quantum recoverable. But that's an option that the community could decide to not have in exchange for not needing to make any consensus rule changes. Because everything else all of the rest of this is not consensus rules at all, because it's all just how wallets construct new notes to send to people.
Got it. Thank you. I would say that I'm slightly nervous about cramming more stuff in Unit 7, but I think this is worth thinking more about. So I think we're going to publish this somewhere at some point, right?
Yeah. This is going to become this Derima has been, as you can see, there is a lot of zip content. This is
we can take a closer look into it later, and then we can talk about it more.
No, Derima there's a lot of stuff in here. The diagram is the most useful thing for a thing. So I expect that to be a zip draft soon cool. for people to be able to look at.
Cool, thank you.
Strad, could you check? Here, let me bring the slides back up. Check the chat. I think a lot of it was covered over the last few minutes there.
Yeah, I couldn't see the chat because Zoom hides it while I was doing stuff. Yeah. I see Sean made some notes. Yeah, it's not a blog post. It's a draft zip. This is basically, Sean, the stuff that we discussed in person at Real World Crypto. Yeah. So, oh, I see he's already gone. Okay, already answered. This does not require a network upgrade. It's only convenient to deploy alongside the network upgrade, and for that one specific case I mentioned, could potentially be beneficial, but that is essentially optional. Zero Darts, what's the timeline to implement this quantum stuff? Worst case could be 3 years. Like, it's the numbers range depending on who you ask. Could be 10, could be 30, but like worst case, given the stuff that we've been seeing, could be as soon as 3.
Okay.
Yeah. Will it delay NU7? Well, the intention of this is that the changes required on the NU7 timeline would be very minimal. This would not be a this would not be on the blocking path. And if it were on the blocking path, then it would be easy to kick out if people decided that we didn't want that. Again, the convenient reason to deploy it along with NU7 is that then we know that every ZSA note is derived in this way, which has simplifying aspects on the on protocol management going forward.
Looks like Zero asked a clarifying question there. 3 years meaning quantum computers that are capable of potentially breaking Zcash, not 3 years to implement the.
No,
what
I
you
didn't
were
mean
just
3 years to implement this. No, this is not a 3 year.
Yeah.
Not a 3 year to implement the thing I just described. 3 years until we might be in a position where we might need to consider turning off the orchard circuit.
Okay.
Depending on how research in the quantum sphere goes. I only say 3 years because you asked for the absolute worst case. I don't think it will be sooner than that, but like I don't have a crystal ball. I can't see further out than that. But this is like, now is the time that people are making these decisions. To give some context, NIST is like the numbers from, is it NIST or CNSA? I forget the specs. I'm not deep in US government specifications, but like the timeline horizon on which people are looking at like deprecating and disallowing like elliptic curve cryptography is 5 to 10 years. Like there's deadlines in 2030 and there's deadlines in 2035. So people are, particularly for encryption stuff right now, people are doing that right now. This falls under the realm of like authentication, essentially. So it's on a slightly slower timeline publicly. Like people aren't upgrading their protocols right now to fix authentication problems. They're focusing on the encryption problems first because of the harvest now, decrypt later attacks, or store now, decrypt later attacks. But we are still getting primitives and things and protocols ready for the authentication aspects, because that matters the moment that people can create inauthentic signatures and stuff like that, and proofs fall into sort of that category. Yeah, the problem here is more one of because notes can live for a while, and particular key trees can live for a long while. This sort of falls into the realm of we can't easily like rotate certificates. We don't have like note expiry on people's funds where you are forced to like spend your note value every 90 days in order to keep it spendable. So this sort of it would instead be a preemptive change to wallets, so that the notes that they are naturally producing for the next several years are plausibly quantum recoverable. So it's a thing I would like more people to be thinking about and mulling over. And so there'll be a better opportunity for people to do that once the proposed draft zip is put up.
All right. Thank you, Strad. Any other thoughts or questions on this topic? I see DC dropped a link that Strad referenced, I believe, in the chat.
Yep, that's the 2035 deadline I was remembering.
Cool. Okay, well, let's do a last call for any other open discussion topics. Okay, I don't see any hands.
Thank you for the crash course. It was awesome.
Yeah, if
Very
you want
cool, yes.
more in-depth information, go look at all of Darragham's talks on this.
ZF website or ZF YouTube channel has a few, at least the ones
Yes.
from ZCon.
Yeah, those are the ones I'm thinking of.
Cool. All right. Thank you all. That next Arborist call will be on the 17th of April at 20. Wait, that's today. So that is wrong, and I don't want to misspeak.
Everybody ready to start the next Arborist call?
Right.
Everybody ready to invent time travel in the next negative 1 hour and 12 minutes?
Let's see. What would it be? It would be
Is it May
1st?
May 1st.
Yeah, May 1st at the earlier time slot, 1500 UTC.
Okay.
There is a
believe.
holiday in some countries, so I personally
Yes.
miss it. Yeah.
Okay. Just
Is
double
this
check the chat.
International Workers' Day. Yeah.
International Workers' Day.
Yes. Not in
Okay.
the US.
All right. All right. Well, thanks again, everybody.
Okay.
We'll see you on the next one.
See you, folks. Thanks, Dan, for
Thanks, everyone.
staying.
Thanks for hosting, Dan.
Thank you.
Thank you.